Hi all, greetings. Today is 27th of November 2025. My name is Dhirendra and I bring over 20 years of experience working with Microsoft technologies. I began my career as a programmer in ASP and C Sharp.net, and over the years I have also been become a certified DBA. Recently one of my client asked me to troubleshoot a new feature introduced in SQL Server 2025, that is vector data type. Today I would like to share my learning with you. In today's session, we will explore the vector data type and vector search. Just for your information, MS SQL 2025 currently is in preview and free to use. When we think about search engines, two key aspects come to our mind: speed and accuracy. So if we think from vector as a SQL database perspective, speed means the data must be stored and indexed efficiently for quick retrieval. In vector search, this is achieved through the new vector data type and vector index techniques, respectively. As far as accuracy, this is more complex. Traditional searches relies on exact keyword matching, but modern applications demand semantic search. Today we will deep dive into the SQL Server 2025 brings AI powered semantic searches directly into database. Some of these diagrams which I use in my presentations I are sourced from internet. This is for better audience understanding. The there are total 20 slides approx in this presentation, and let's begin. So before going deep into this presentation, I thought to keep this one slide to showcase that what we are actually going to do. So we start with AI basics. That means we understand what is vector, not vector data type, but first let's understand what is vector, and then what is vector search, and then we will uh, give a slide for an embeddings, because this is a very important part uh, of the search. Then we will relate them to the SQL Server. That is, we actually understand what is vector as a data type. Finally, uh, we will create a query, basically because to make the things easy, I am not using the uh, SSMS, but I am showing you the create, insert, and update scripts directly on the presentation itself. At the end, I have kept few slides for developer. Of course, this is a development side to make these this crude examples like create, insert, update, search, everything. Okay. Besides this, I have also kept a few performance tuning related slides. So other than CRUD procedures, we will also look some part of the tuning and storage, how it will help for DBAs. Okay, so this part, of course, create CRUD is the part of developer side. Okay, so let's begin. Uh, so before going further, let's take a step back and refresh our understanding of AI fundamentals, because this is very much important. And anyhow, you all knows, whoever comes to this presentation, that vector is a base for an AI. So let's clear our base so that we I'm expecting that this PPT will be viewed by freshers also, so that's why I'm keeping this one slide. So this will give us a foundation before we explore how vector fit into the bigger picture. So things that aren't AI but people think they are. So some people think that okay, Excel macros is an AI, but it is not. It is just an autofill. Some are saying that okay, autocorrects because it is fixing my typos, it's an AI. No, it is not. It is just a predefined dictionary. And automations. Even I found in meetings that when people start talking about AI, somehow discussions moves into the automation. Automation is always there. So automation is not an AI, because we are whenever we are doing SQL jobs, whenever we are creating any SQL jobs, it means we are creating automation. So of course, automation is also not an AI. So what is an AI? If I go with the definition, AI is the ability of computer systems to perform tasks that typically require human intelligence, such as learning, reasoning, problem solving, and decision making. I also find a good clip uh, from an internet. So basically, when I am asking in a simple term, if I'm asking when we use an AI, we are essentially saying, hey AI, bring your intelligence and help answer my queries. So AI enables computer to think, learn and make decision. Similarly, how we humans do, without being explicitly programmed for every single task, like autocorrect or automation. This means AI systems can analyze data, recognize pattern, and continuously improve over time, making them smarter with experience. Basically, we train them. So here are some funny quotes I found over internet to showcase what exactly AI is. A robot in a suit saying, I have optimized your coffee break for maximum productivity. Human, I want a pizza, where AI is saying, based on your calories intake, I recommend a salad. Human, you are fired. Just this is just a jest. What I'm trying to say here, that AI is not a simple question answer machine, but it will put its brain before giving a answer, which means it knows, it having a capability to analyze. For analyze, of course it should have some mechanism, some language on which it is doing all these analysis. So now when we are having a basic understandings of AI, let's move on to the next slide. So why we need a vector search? Because we already having a basic search and SQL. Uh, to strong to make this belief more stronger, I have put that slide which we just shown in last slide which I have shown. So in that slide I have told you that it is not a normal search engines, but nowadays search engines are required with brain. So why do we need vector search? In normal example I have tried to bring it on this slide. In traditional SQL search relies on exact keyword matching. If keyword isn't it an exact match, the result is often irrelevant. While vector search is typically a semantic search. Okay, what I mean to say here, that in our normal search we generally used where conditions, and we go with the, at most we can go with the like, otherwise it will go with the exact match. I am saying ID should be equals to this, I am saying employee name equals to this, something like that, correct? But it can't bring the semantic search. However, vector, when we save the data in a vector data type, our main purpose, our end goal is that whenever we put a search, whenever we try to do a search, it actually give us a semantic similarities. That means by putting his brain, AI will, its brain, if AI will analyze the things, and on the basis of my question, that computer, that AI will give us, that machine will give us the answer, and not just a exact matches. It is not just an exact match. So instead of matching exact words, semantic search focuses on meaning behind the query, finding the closest conceptual match, basically. So if you ask the examples of semantic search, then there are AI models like OpenAI, BERT, and Clip generate embeddings which place similar meaning close together in a vector space. This allows the system to understand the context and intent, not just the keywords. Now, vector search can be considered a specialized form of semantic search. Okay, so vector search is, you can call it as a option of a semantic search. I mean, it's a root of a semantic search. The key difference is that while semantic search aims to understanding meanings and intent behind the words, vector search operate on the mathematical representation. Okay, so semantic search, when I'm saying semantic search, how it is different with vectors. Vector is a type of semantic search, you can say, but it relies on how SQL is working on this vector search, that it actually creates a mathematical representation so that it is easy to compare between two mathematical objects. Correct. So it is easy to make a relationship between two objects if I consider them. If I give, suppose there is a word uh, ABC. Suppose for A I giving 1, and for B I am giving 2, and for C I am giving 3. So that means there is a close relationship between A and B instead of A and Z, because the difference between A and 2 is less. Correct. In that way. So basically, vector data type is putting the data in a mathematical representation. So this is basically, we will discover all these things in our later slides also. So this is the basic slide why vector search are required, and as we all know, AI is the basic intent why we need the vector search. So vector search and vector data type are the base of the AI search. Now, just understand this with an example. How does semantic search work in real world? Suppose I need to fix my dining table query. My query is how to fix my dining table. It is not something like I'm putting where in my real world. I'm not putting where ID, something like that. I just need how to fix my dining table. And on the basis of the semantic search, it will get a match that list of the carpenters nearby me. So what I am actually want is to fix my dining table. But the keywords are like how to fix my dining table are totally different from the exact match what it finds, that is list of carpenters nearby, and actually I'm looking for carpenters. Correct. So again, in a nutshell, vector search captures the meaning of the query and returns the semantic similarity search even if the words are different. Now the question arises, how does this vector search actually work? The logic lies in how we store the data. First, we need to convert the data into mathematical representation. This can be done by us by using our user-defined embeddings or AI-defined embeddings. Then we store it in SQL vector data type, column of a table. What is user-defined embeddings? What are user-defined embeddings? So this from this diagram, let's try to understand that whatever objects of real world, object 1, object 2, object 3, like table, chair, anything, okay, this will be changed in a mathematical representation. So table, suppose table is 1, chair is 2, and this is a tree, it is 0. So there is a relationship between these things. But suppose there is other object iron, then it will be 100. So there it is not close match to these things. Okay. And similarly, when we are focusing on alphabet, words, and sentences, these all we can put in an embedding in a mathematical order, and then this embedding actually stored in our database, and that database column is a vector data type. So what type of column it will be vector data type, because it's a long embedding. I will show you an example. Okay. So just because we said here embedding, so what is user defined embeddings? As I said, there are two types of embeddings. One is user defined, and another one is we can use uh, the embeddings from AI itself. where, so what is first, so what is user defined embeddings? A vector in its pure form is just a list of number in multi-dimensional space, a mathematical object. This means we are using our own custom logics but not AI logics. In a nutshell, what I can say, suppose I am putting, because I know, okay, this is my vector type and it is a, basically it's a float. So I just put a number like 0, 1, 2, 0 0.13, 0 0.85 for each and every vector. And on this basis, I am not using I am not taking any help from AI or anything. I'm making my own numbers and putting there on the basis my business logic. That business logics are only clear to me, and I'm saying, okay, this is my business logic. Let me give the preferences on the basis of the of these all objects. I will give the preferences on the basis of my experience. I am giving the vector type, so I am creating the vector type, I am customizing it. Okay, the second way is uh, let's see, um, the second way is AI embedding. So when I'm saying AI embeddings, basically AI embeddings, when I am asking an AI to create an embedding for me against this object one, again, then for this object two, and then for object three, and then that embedding I'm storing in my columns. So that is called AI generated embeddings. Okay, so there are two types of embeddings. One is in its pure form, that is when we are consuming. Okay, let's take a example for this, understanding why a vector matter. Imagine in your organization, you have a DBA team. One is for SQL and other one is Oracle. Each team has 5 DBAs plus an HR team with 2 members. Now, to make it interesting, suppose both DBA team have a member named Arun. I can do this without this example, but just to understand thing better. So, if we store this data as a vector, we can assign numeric representations. See, suppose I am having these teams. One is DBA, and it is having SQL DBAs and Oracle DBAs, and then there is another team HRM, that is these are having HR. Okay, so what I am trying to do here, I am putting my embeddings, my this is a vector data type, this is a team member. On the basis of this vector type, I can say that this Arun and this, see, there are two Arun, one and second. So I can say on this basis of this understanding, I can say this Arun is from SQL DB team and it is more close to Ajay and Bridge, because it is 1.02 and Ajay is 1.01, as compared to the Avinash, because Avinash is from Oracle team, that is from, and its number is 2.001. So this is the vector understanding what I have given to the system. Okay, similarly, the HR, I have given HR a number is like 9.02. So these are just example. These are not exactly how you have to arrange it, but this is just for giving you a glimpse that how AI, what I am trying to say here, that what is vector type and how it is actually help in searching. Because if we are just storing the data, then there should be some purpose why we are storing them in this view. So if there is any query comes, like suppose I am putting this data in this way, but after this, if somebody queries me that what is the relationship between Ajay and Arun, is Ajay is more closer to Arun or to Avinash, this, whenever this questions comes in, on the basis of this stats, they will say on this company, on the basis of this company, in this company, the relationship between Ajay and Arun is more stronger than Avinash, because they are from a different team. So this is just for your example. Similarly, if I use AI embeddings, suppose I created some procedure and I ask AI to create an input. Suppose there is a word you, me, they, anything, correct? So I ask them to give me an embedding for you. So it will give me a long embedding which I am actually putting in my database. So here, how I am generating this embedding, I am asking, okay, suppose I import a model. In next slides, I will show you all these things. For now, just understand that I am asking AI to give me an embedding against a word. and that I am putting in my vector data type and not generating any vector type by my own. So these are AI generated vector data types. Okay. And yes, of course, because we are talking here all these things that how AI, if somebody asks me how, because here I am by myself putting these values 1.0 1.02. Okay, how when embedding created by the AI, how AI is creating these embedding with the help of NLP, natural language processing. Okay, and with the help of these natural language processings, these, which is again, so in a nutshell you can say an AI is creating an embedding for AI. Let's okay, let me also tell you that when we are talking about embeddings, so this embeddings is also a vector but generated by AI models to capture semantic meaning of data. These AI basically, for example, doctor and physicians having most you can say a close match. If I search doctor and physician, then the relationship between a doctor and physicians are more close than if I asking a carpenter how to fix my dining table. Okay, so if I ask a carpenter, relationship between a carpenter and doctor, of course it will not be that much closer. So one more, because see, we are talked so much about the vectors, so there is obvious one question rises that if vector is an AI, uh, if you see this diagram, so this is uh, example of AI, AI generated embeddings. So if you ask me that if vector is an AI, so yes, in function it enables the semantic search, which is a core of AI. Correct. So without this embeddings, a proper AI search is not possible. So yes, if you say function wise, yes, you can say, but like architect wise, if you ask me, so it is just a mathematical technique. What we are doing in vector, we are just putting some mathematical numbers. See, what we are doing here, we are just putting the mathematical numbers. So how can it be a AI? So no, it is not an AI, but it is a base of AI. On the basis of this number, the final AI search will be powered, AI powered search. So this is a key enabler of AI powered search, you can say, vector. So and it doesn't generate or interpret embeddings. That's done by AI models by itself. Okay, so yes, we can generate, uh, we can put our own, but normally uh, in a bigger picture we normally use the AI generated embeddings. So that's why it is not generating, and even it is not interpreting. It doesn't know when it is storing the data, when it is storing any data, any embedding, it is storing any embedding. My SQL server doesn't know anything that what is it actually. SQL is just storing the data. How it is related, how it is interpreted, everything is done by AI, which is work on the top of these vectors. So vectors are numerical representation of data typically generated by machine learning models to capture semantic meanings. Vector and vector represent everything from human world. A vector embeds the semantic meanings of a keyword and phrase from real world. That means the vector has an embedding for keywords like you, me, manager, employee, employer, king, queen, fruit, vegetable, dog, cat, India, America, Europe, Beijing, etc. I mean anything, or for sentences also. If a sentence, for an example, a man ordered coffee converted into vector, then a similar sentence like a man is sipping from a cup is closer vector in space. I mean, if we if we are saying that this we are fetching this data, we are fetching this embeddings from AI, that is from a AI space. Okay, it's AI is its own world, correct? It's having its own world. So if we are fetching this embeddings from AI, so in that world, a man ordered coffee sentence is a close match to a man is sipping from a cup rather than a man is running. Of course there is a relationship between, because both are man, so there is a close relationship between man is running, man is eating, man has ordered coffee, then a dog is barking, then anything else, lion is I mean everything, there is a vector embeddings, and these are not just a simple uh, data. These are not just simple ABC 1 2 3 things. These are actually huge strings when it is coming from the AI. When we are creating it, these are the vector data types. So these embeddings allow for semantic similarities comparison using mathematical distance matrix. Now, when we understand what is vector and what is embedding, let's focus on what is vector data type. Let's put things for MS SQL. Let's focus on MS SQL side. So what is vector data type? The vector data type introduced in SQL Server 2025 is a major leap. We understand what is vector, and now what we are trying to say, what we are trying to uh, learn here, what is data type, vector data type. So the vector data type introduced in SQL Server 2025 is a major leap forward for integrating AI and semantic search directly into relational databases. The vector data type stored an ordered array of floating point numbers typically generated by AI models to represent the semantic meaning of text, images, or data. It's not only about the data, it's everything. It can match the text, images, and other data like report files and all these things. So uh, vector data type, basically there are parts of vector data type. The first part is dimension. Okay, so number of element in a vector data type should be minimum 1 and can go up to 1998. So when I am saying number of element, it means number of dimensions. This vector can have minimum 1 dimension and maximum 1998 dimensions. Okay, and because it is a float 32, if we make it float 30, if we make it from float 32 to float 16, then it will go up to double, that is 3996. Then it can go up to 3996 dimensions if I am putting it a float 16, if I'm making it. Okay, and what is dimensions? We understand what is vector. Now what is dimension? Let we discuss these all things in next slide, because it's a important aspect of vector. uh, Here is an example how to create a table. Suppose I'm creating a table ABC and the primary key and a title and varchar. Then there is a column embedding, which data type is vector, and what is 768? 768 is a dimension. So suppose I like in n varchar I am putting 200. That means that I can insert up to 200 characters and varchars. In similar manners, in vector, when I am putting 768, it actually means how much dimensions, how much, how many dimensions I am expecting for this vector. So let's talk about the dimensions and why it is matters. When we work with embeddings in AI, the number of dimensions determine how much detail we can capture. Okay, the default and most commonly used dimension size in OpenAI models are 1536 and 1024. 1536 and 1024. But you are not limited to that. You can choose any number of dimensions between 1 and 1998, typically represented as a 32-bit floats, as I already shared. Now, the richer your dimensions are, why these dimensions should be high? Okay, I can use one dimension, and one dimensions mean it is very the storage size is very low. But why I need high and rich dimensions? The richer your dimensions are, the deeper the information your vector can hold. For example, suppose let me create a dimension with 128. Okay, suppose I am creating here a vector 128. That means I am giving a 128 dimensions something. So we can capture basic word meanings, like it can distinguish between a car and bike. So if this vector type is for car, it can understand, okay, this is a basic difference between a car and bike with this. But if we make it to 768, it will, as generally 768 1024, these are the terms which are actually used by the models like BERT and OpenAI models. So many models are using dimensions up to this. So what I'm saying, yeah, so if I put it in a 768, in that sense, it can also differentiate between a car and a car insurance policy. So the word is car on both sides, car and car insurance, but they are actually totally a different things. uh, on an example, if I say, suppose there is, I put this embedding for fruits, so I put here as an orange. So my vector understand, my 128 vector understand, okay, this is a fruit. But if I make my vector richer, like I put 768 dimensions, so it will understand, it will go in the more dimensions, and it will understand, okay, orange, there is a company name with orange. Okay, so it is not only restricted only to the fruit, but it also capturing the details of a company which named as an orange. So what I'm trying to say here, why the how richer your dimensions are, how big your dimensions are, the deeper information about this it can hold. This embedding can hold the richer dimension. So why I'm putting it embedding, I'm just naming the column name as embedding, because actually embedding is a vector. So I have already shared, I've told you this, what is vector. Vector is a search, embedding vector. uh, it's you can name any column. I'm just, for your easiness, I'm putting it as an embedding, but you can name it anything. So what vector is storing it, it's storing a embedding. Embedding can be of two types. One is self created, and one is AI created. And how much definition you need of that particular object. Suppose there is an orange, so how much definition about an orange, about that word you need from an AI. It depends on this dimension, how big dimensions you are giving to that particular word. So if I am giving 128, it will take the normal data, like orange is of orange color, orange is a color also, orange is a fruit, its locations where it is found, something, and all these data. So that when the search comes in, suppose someone is asking a price of orange, someone is asking color of orange, someone is asking what is orange, so all these can be answered with this single vector, because it is having all this data. But it can't, if I'm putting it 128, so it can't answer the query of the type of orange company worked, or what type of how many employees are there in orange company. So that richer dimension, this will not become a that much richer dimension. Okay, I hope I understand, this point is clear. So in nutshell, higher dimension allow model to encode subtle difference in meaning and context. How clear my dimensions are, how richer my dimensions are, that that depends how clear I can answer the question. Here, uh, so let me give you one more example before going into the create statement. So because we talked about the images, suppose there is an image of Taj Mahal with a 64 dimension, might represent simple shape and color of marbles, and how it looks, something like that. But if I put a suppose there it's not Taj Mahal is not a word which only I am using. I am using for a different purpose. Suppose I am having a marble company, so I am just need the marble definitions. So what use I will use a vector with the 128 because I just need the uh, marble that is used in the Taj Mahal. So I am showcasing that also selling that particular marble. But if I'm a company or I am Indian government which is actually focusing on tourism, so I need the much more data about the uh, Taj Mahal. So I will get 2048 dimension as used in deep CNNs, capture fine-grained details like texture, pattern, object relationships. Basically, more dimensions means richer representation and better similarity search. So, if a tourist asks for sitting in abroad, asking for uh, good places to visit in India and wants to deep dive into that, what are the things? So, it is located in Agra, besides river, so what is the name of the river, what are the villages besides it. So all these things can be captured in this vector if I make it on the. So I'm not saying that exactly these information are there. I'm just trying to give examples that if you having a richer dimensions, then of course you can answer more and more queries related to that object. And these all are the base of the hybrid searches. Hybrid searches are the combination of the old search, which is our exact match, and the new searches, which is semantic searches. So it is started with exact match Taj Mahal, and then it will take the semantic data. So that is a purpose of an AI. Now, there are two. Suppose when I created, so the second thing is how to insert the data in this create table. So when I created this table, okay, one thing, I can't put image in this embeddings. So if I am having an image, it should also a primary key, but I put the features of that image. So that's I just shared that I can put the embeddings about the Taj Mahal. I can't put the direct image into this embeddings, but I can put the data about that image. So whenever someone is asking about that image, this on the basis of this data, you can show AI can show the Taj Mahal picture, of course. So now let's see that how to insert the data in this. So I've created this product ID. So I'm inserting the data. So while inserting, there are two options as I said. So product name and embedding I'm trying to say here, feed here. So product ID is one and the name is wireless mouse, suppose, and for this wireless mouse there should be some embedding. So either I can put my embeddings. Suppose I am having a small shop or a particular company who is making the mouse. So for me, I can put this mouse in a same category. Suppose a normal mouse with 0.11, the wireless mouse with 0.12, wireless mouse with light, something like that. So I can put here my own embeddings. Okay, these embeddings custom embeddings and are generated by me. Remember, I have told you there are two types of embeddings, and this is the embedding which is actually generated by AI for AI. How can we use this? So there is an function in SQL Server, that is AI. This is a default function of SQL Server, AI generate embeddings. Okay, and then to use this model, we can't use this function. I mean, you can use this function, just this function. You need some model. This function required these parameters: model name and input text. We have this input text as wireless mouse, and we are using this model to find the wireless mouse related embeddings. So because we are not having this model, so we first need to import this model. Okay, so so there are basically, if you want to import this model, there are three steps. First, you need to enable enable it in SP configurations. In SP configuration, you need to enable the scripts. Okay, it is like sp configure external scripts enabled 1. Okay, and then you need to then basically there are the queries. You can find these queries anywhere in internet, where whichever model you want to uh, import. On the basis of that, you will find the queries. Suppose you need this OpenAI embedding model, so you need to put the it's like 20-30 lines code, and then it will be imported, and then you can use it. Without that, you can't use the AI. Okay. Yes, you are having this function which will help you to import and use this model. So once you put this data in a table, how tables looks, it will generate. So this, because otherwise this is a huge string, which I'm just saying is huge string, but it is actually how vector data type looks like. So this is a vector data type, how it looks like. If you use this, uh, if I try to show you how it actually looks like, then it will maybe on the basis of the vector 1024 dimension, or on the basis of the vector 1536 dimension, this will be uh, take a full page. I mean, in SQL you can say it will go beyond the one beyond the 8 KB pages. Okay, so I am just showing you here an example. If you see that it is three dots, it means it is going beyond than this. It is not only about this one one page and SQL. That's why I'm saying 8 KB pages, because one page size is 8 KB, correct? So this is how we can insert it. As and What else I can say here? Yes, as I said that you can use multiple models. So if you want some models name, it's like OpenAI as I used here. So there are Azure OpenAI local models via Olama you can use, uh, or any HTTPS compatibility embedding services you can use here. So what it means that we can code a word or a sentence and OpenAI and give them an embedded string, a huge embedded string, and the size based on the number of dimension we chosen. And AI considered this string as a sequential number, a point in a high dimensional space. On the basis of this number, AI calculate the distance, that how these words are closer to each other, closer or farther to each other. A number that helps in doing a semantic search. Okay. So basically, because we are having this representation, this embedding, it actually, the similar word, it actually calculate our distance between two words. So as we all know, computer works with 0 and 1. For computer, everything is 0 and 1. It, okay. uh, it's his low level language over the beside underneath the high level language. Similarly, on the basis of embeddings, AI actually works. So for us, word is like food. Is a we understand a word food, but AI, for AI, it's a sequential number. How an AI understand a food is a number created by AI for AI to understand the meaning of that particular word, that is food. Suppose this is embedding for a food, so it understand. Okay, whenever uh, AI get this word, it understand, okay, we are talking about food, and on this number, on this numeric huge numeric number, it is actually having a close match. Okay, now we have created the data, we have insert the data. Now the part is that we have to read it. Now we have to read this data. So for reading this data, as I said, that now we have numerical representations stored in a vector data type column. For each keyword or sentence, it becomes easy to calculate the distance between these two vectors. This essentially means we are capturing the relationship between those two keywords or those two sentences. Now, why do we need matrix? Here is a new word introduced after model, that we need a metric. So this icon is actually a metric, that on the basis of select top, when we are putting select top 5, it will, because the data is saved in embeddings, so our normal search can't read it. We can't go with the where clause. We need a metric to search that data from the column, from the embedded column. And these are the uh, types of metrics. Okay, so this is a default metric. It is known as Euclidean, and you can also order by the cosine metric. So this is an embedding. This is an Euclidean embedding, which is a default. So this particular uh, syntax, this particular symbol is for Euclidean, and embedding we had used here. So here I am asking here to give me a result, top 5 results on the basis of the Euclidean embedding. And here I am asking with the help of cosine distance. Cosine distance is a different type of metric. These are the metrics, default metrics. This embedding word is wrong. This is a default metric, Euclidean. So its name is embedding Euclidean. That's why I used it. Otherwise, then this is a metric. So metric is a, what is metric? Metric is a way to how to find the data, how to search in vector columns. We need metric. So metric is a mathematical technique, again, because it's a mathematical data. So again, this is also a mathematical technique that measures uh, on the basis of our data. Suppose some data, like in where condition, we are having dates type of data type, we are having where care. So there are multiple type of data, na? So similarly, on the basis of the data, suppose in some data we need only directions. So on the basis of the direction, distance, angle, it actually take out the results on the basis of the uh, metric. It will give you the relationship or a uh, uh, difference between two data. So when we are getting a difference between a mathematical representation, as I already shown in the last slides, it will also get the relationship between the two data. So there are multiple type of metrics: Euclidean, cosine, dot product. So there are different types of. You can check this over the internet. Suppose like for an example, this cosine distance is basically measures the angle between two vectors. And Euclidean, it's a straight line distance between 2 points in a dimensional space, based on the geometrical closeness. Okay, so if you need to think, find something which is in India, and other thing which is in, so basically if your search is geo based, geometric based, then you have to use this Euclidean. Dot and other than that, there is a dot matrix. Basically it define it search on the basis of the ranking. Dot product, and similarly there are so many. Now now when we understand how to create, how to insert, and how to select, the second part of our first slide comes here, that how to fast this search, because these are embeddings, these are heavy data which are stored. So the purpose will not solve until it will give us the results accurate and faster. So when we need a faster results from vector, then vector indexing comes into play. So we need to create like a normal indexing we have created on our data on our table. Similarly, here we are creating the DiskANN algorithm. Okay. So what we have, how we are putting this index, this is a DiskANN is an index type. So I am of course, if you at the time of creating this table, you can put this because now I am having the data, this column already created, this table already created. So I am creating the index right now. So on the basis of this, on product table, I am creating a DiskANN type, and the metric I have used cosine, and the dimension it is 1536. This should be same. This should be same as the embedding vectors that create table. Whatever definition I have used for embedding vector, this should be same for indexing also. Now, if anytime your customer says that my uh, vector column was very slow, so you just need to create an index on it, DiskANN index on it. Because it's a good topic, I have created one slide on this. So, what is DiskANN? DiskANN basically, the abbreviation is like disk based approximate nearest neighbor, is an algorithm and index technique for vector search. What it does, it actually like Neo4j, and if anybody of you work on this, so it is also build a graph based index optimized for faster and the nearest neighbor search on large data sets. Okay, and once we have created the DiskANN vector index on the product table, the index is automatically used when we perform the vector distance comparison in the order by clause. So this is neither to say, because we all knows that if a table is having an index, it will automatically used. So okay, so the same query will use the same query which I have used in last page. If you run after creating the index, it will become faster. So basically, this designed for disk based storage, uh, not just in memory, but it is used, or it is making it scalable for billions of vectors, used in SQL Server 2025 for vector indexing to speed up the similarity queries. And of course, you should understand that that DiskANN does not define how similarity is measured. It only accelerates the search process. That part is of model, that part of is metric, not model. That how much how similarity has been measured, it is done by the metrics. Okay, so all three, I hope all threes are clear. All fours are clear. What is embedding? Embedding is a vector. Embedding is a basically embedding. We are saving the embedding in vector data type, and then we can use for creating those embeddings a model, and to search from those models we can use a metric, and to faster it, to speed up the things, we use the index. So DiskANN is an indexing and search algorithm, you can say, in a nutshell. Now there are some limitations also. So now we almost understand that what is a vector data type. So there are some limitations also, so that I have put, that I have already shared, that it can't store the images, of course, but it can fine grain their searches, correct? So semantic search are the basics of the AI model. For more fine and grained searching it is used, but it is not AI, because semantic searches has limitations and it get confused if we are asking for same words having multiple meanings. I mean, this is a limitation, because on the top of this, AI actually understand that if question has come for orange as a food or orange as a company, this search will only give the top 5 results. What it what AI ask, AI give him, okay, this is the embedding, please give me the most closer nodes, most closer embed other embeddings most closer to this. On the basis of that, data will fetch. How data will fetch? If you see, there is if you see the column, we are having a ID column here. If you are following this, here we have created 3 columns: product, ID, embedding. On the basis of embedding, it will go with the relationship foreign key, primary key relationship, and it will fetch the actual data, actual product ID. Okay, it's a simple search, but it is done for only a wireless mouse, but it can, if it is related to some other table, some bigger table, it can manage that data on the basis of this embedding. It can take out the results on the basis of that embedding. Okay. So semantic search with AI can give better and best results. That means semantic search are the base of AI, but not an AI in itself. This is not an AI itself. This is a major limitation. All these things, all are these things are the use cases uh, where you can use it. You can store images, embeddings, perform similar search on visual content, group or tag document based on their semantic. As I said, documentation, you can search do semantic search on the document basis. Like suppose I need all the documentation of person A from different storages. Okay, so on the basis of the ID and the embeddings, you can do this. And there are not only I mean, there are deeper searches are also available on the basis of the document. Just need to follow on the document if we need to do. If you found a semantic searches like this document related all these document, I need, there is some cases happening on court, and I need all the documents related to this till 2010 to 2025 example. It is also helpful in fraud detection, legal compliances, all these things, chatbots, memory, context, product, wherever AI is used, wherever you can think an AI is used, most of the cases you can also find the uh, storage vector type is also there. Okay. What is the expectation? Of course, the expectation is to give a it's not a future, but it is also in used. Okay, so basically the purpose is a hybrid search which uses both sides, the exact search as well as the as well as the semantic search. Okay, so what is RRF? Basically, reciprocal rank fusions, we call them. So RRF is a re-ranking algorithm that used in hybrid search. It merged multiple ranking lists, example form, full text, and vector searches, into a single unified ranking. It gives higher priority to items that appear near to the top of any list, even if they don't appear in all lists. So in no more details, so in more details, so in more details, full text search is what we known as a keyword based searches that is using BM25, the algorithm BM25, correct? A mathematic formula basically. And vector search, which is using a semantic similarity using embeddings. RRF, what RRF do? RRF help to merge these lists, these two searches into a single output. More relevant, it will give us the more relevant results. Okay, and how it is doing it? It is setting this all in a score. Okay, so that's why the algorithm called RRF, reciprocal rank fusion. So when I'm putting a score, so the best top 5 match will come to me if I'm asking select top 5, correct? And of course, B tree is not a full text search. I mean, I thought that it is also helpful when I'm saying talking about full text. And like clause are like perform pattern matchings. So what if I see in this example, I mean it's all clear, but still, if someone is asking for uh, basically what is happening over here, if someone is asking a query, we are giving him a best of the searches. That is, we are including the vector as well as exact searches and giving him the answer, not exact answer, not a wild answer. If he is asking for an orange as a company and I am giving him orange as a fruit, then this is not a right. And similarly, if he is asking for an orange and I am just giving him an orange without a deep knowledge, then it is not a intelligent search, then it's not an uh, analyzed or AI based search. Okay, now this was a SQL uh, about till here. This was a development side work. So how to use the CRUD functions, create, read, update, delete. And here let me talk about a few minutes for the DBA sites. Of course, you can pause and use these slides. So these are the basic uh, data which you can read and understand. These are the simple understandings. Mm, So table design and data loadings, keep vector columns separate from the metadata, of course, because these are the heavy tables, heavy data. So in actual tables, if you are creating, there are 20 columns in a table and you are creating an 21 column with a vector column type, then it will become, the table become huge. And if other than the vector searches, suppose there is a simple queries, then it will be, the performance issue will create it, because uh, there is one column which is having a huge data. So instead of going into that, it is always ideal, it is always recommended to create the vector tables and data types, and these vector data types basically a separate table, and like I said, that create a ID column, and that it will do. Use bulk insert or JSON import for large embeddings. Yes, one by one is like it will take much time. So instead of inserting embeddings row by row, which is very slow, use bulk operations or JSON based import for efficiency. Okay, again, you have to import JSON. Validate, I mean, if you are already using this is not to say. You already understand this JSON, how to import this. Validate vector dimensions consistently before load, because if the, as I said, that if the dimensions, there is a difference between a dimension, suppose the dimension is 1568 and you are trying to uh, load it in some other vector, in some other table which is having the same vector but with a different dimension, then it will not work. Okay, it will give you error that there is a difference of one dimension, so some error will generate. Okay, so basically, when I'm saying validate vector, ensure all embeddings have the same dimensions as your vector column definition. Okay. Otherwise, SQL Server will reject the rows if dimensions don't match. Configure vector support. Ensure SQL Server 2020, of course, because before this feature will not be there. So you need at least SQL 2025, which is still on preview but a free. Uh, you can use it free. Anytime you want to use this feature. Use supported drivers, of course. Features enabled by default. Verify via systypes and DMVs. You can also check that if this feature is enabled or not with the help of these. Backup and restore, it is normal vector data type, fully supported native backups, always on, validate and index after restore. All these things are normal. Okay, select, I mean, if you are DBA, you just have a curious about this. That's why I put it over here, that if it is support always on or application. So yes, it is, and you can take the normal backups. Validate and index after restore for failover. Always do this, and here is the query. I have put it here so that you can rebuild if required. There are few monitoring DMVs. Monitoring DMVs, there are these few DMVs which will help you to monitor this. Index search, yes, you can do index searches, as I shared how to create this, how to rebuild this, and try to rebuild this periodically as we. So these are normal index. If you, being a DBA, you understand that we are rebuilding, we are reorganizing the indexing whenever required. So similarly, the same law goes to this index also. And yes, one thing, when we are saying backup restore, because it supports the native backups, but again, you should have to understand that, of course, it was looking like an embedding. If when I show you data, it looks like an embedding, or sometimes you feel that okay, this is also an encryption. No, this is not encrypted. So there, what we did, we ask AI to create an AI data, AI embedding. So that means, and after that also we ask our matrix to take out that data. So both things understand what is the exact meaning of that word. That means a model understand what is the those, if anybody from the outer world having the same model, because that model is available for all, so that person with the help of that embedding can do the reverse engineering. So be safe, put your data TD enabled. I mean, just putting a this vector type column, it doesn't means that it is an encrypted one. But anybody can do a reverse engineering. So never be confused that okay, I have a backup and I have a restore. I have stored data in embeddings, so nobody can dig the data what I have stored. It is diggable. It Anybody can do the reverse engineering with the same, by using the same vector type, by using the same model and matrix. Okay, then troubleshooting common issues. So normally, what type of issues you found? Like as I said that my one of this client asked me to do this. So he is actually facing the same issue. So there is a mismatch while inserting. So he is using the same insert command, but there is a difference of the dimensions. So that's why it was not running fine. So these are the basic problems which you can find. An index not supported on partition table. Understand this also. If there is a partitioning table, if you created a partition table and put the one column as a one column as a vector type, then you can't able to create the an index. So uh, sometimes people say that okay, it is a huge table. This is a this required a huge storage, so let's make a partition table. So you can do this, but after that, an index will not work. Verify drivers and compatibility level if error occurs. Yes. Keep vectors dimension reasonable. I mean, though you have an option to put a vector with one dimension, but always keep it at least 1024 or 728, something like that, more than that, for better results. Otherwise, there is no use to make a vector column. Correct. Avoid mixing OLTP and vector workloads. Partition data logically by embedding type. What I mean by saying this, create a separate table and uh, uh, create a separate table for embeddings for vector type, and create a primary key, and always try to create a single table for one embedding. Okay, that will be more uh, recommended approach, I can say. That will be more, because see, uh, this will be efficient when you are taking out the data, when you are trying to search, instead of searching from a table which is having more than one vector type columns. It is always easier to find the data from a single. However, in case there is no other way out, and you found that okay, I need a table with multiple vector type, then normal suggestion is to create a one more column. So suppose you are having an ID column and you are having four or five vector type columns, then create one more column of embedding type. This will help in doing a partitioning of tables, and if it is not in partitioning, still it is better to use this column. uh, like see, an index will not work with partitioning, but if you are having this particular column, ID, instead of ID, but there is an other column like embedding type, you can use this in your partitioning views or filtered indexes. I mean, if you really require multiple vector type in a single table, it's always good to have a embedding type column. So partitioning data logically by embedding column, or you can this will help you in while you are searching while putting the where conditions and all this. And what is the rest I am having with for you? Maintenance housekeeping, it is just schedule index rebuilds, as I said, regular validate the dimensions, monitor growth, separate vector workloads and transaction data, I have already shared. Keep embedding stable slim id plus vector only, that is the good approach, as I said. Test and performance under production load also, because there may be, this is a basic understanding for any DBA, so for any index. Okay, so performance may differ under production and a UAT or a sandbox. Limitations of vector. So we cannot store an actual image or audio file in vector column, as I already shared. However, we can generate an embedding from an image or sound. These embeddings are numerical representations that capture the semantic feature of the original media. Storing these embeddings in a vector column allows us to perform a similar searches, making it possible to identify or retrieve the original image or sound based on its embeddings. Security policies like RLS, I've pointed out here that see, no primary key, etc. on vector columns, cannot be used in memory optimized tables. Some features not supported yet. Cannot be used in memory optimized tables. Some features are not supported yet. Always encrypt ledger tables. Vector index limitations, cannot create a partition table, cannot create it on partition table with security policies. So this part I have already told you, but it will not work on partition table, but it will also not work with the security policies. So security policies means RLS, row level security. So what are row level security? I mean, being a DBA, you all know that uh, on the basis of the roles we have given the permission on a table. So if that has been done, it will not work. Okay, vector index will not work, DiskANN will not work, because it actually uh, because see, some rows, and if you are putting a RLS, then there are some hidden rows which from certain users, and suppose you are using that particular user, then this can be lead to an incorrect or incomplete search, because that user which I am actually used to create that vector, it is not having the access to all the rows. Okay, in that way. So best practices, of course, store only embeddings plus key in vector, that I have uh, cleared multi times. And yes, we cannot store an actual image, but we can do this in a other way, as I just said. And that's all. This is our final slide, that is 20th slide. And here this diagram I have captured from the internet. And so the data can be any of any type. It can be audio, image, document. Okay, and then it will be embedded in a model, and this embeddings comes with an index, and these embeddings are coming from AI, or we can create them. Okay, and then finally on this all on the basis of all these things, these embeddings stored as a vector type here, and whenever is required, it can be accessed and with the help of the matrix. Okay, this can be saved with the help of models, and this can be searched with the help of metric. That's all from my side. Thank you. If you are having any questions, you can comment on my channel. Thank you, and if you like this, please share and subscribe. वाहियात बात है. Thank you. Bye.